Sine rule. Well, the sine rule you did at GCSE, but it now reappears in Call 2. Now, the equation you used in GCSE is the one shown. A over sine A is equal to B over sine B, which is equal to C over sine C. Now, we also, when you did it at GCSE, would have looked at labelling the triangle as shown here, where the capital B, the angle, is opposite the side with the little letter B, and the same with the A's and the C's. Now, what you found, as I said, is that those three bits are equal to each other. Now, this can also be used to find the angle, and once we've done the first example on finding the missing side, we'll look at finding the missing angle by slightly rearranging this equation. Now, we're never going to need to use the three bits, probably. We're probably only going to have to use two of the parts. So, let's have a look at an example. It says find the length x. Here we've got a diagram shown. Now, it's really important that the first thing you do is to label this shape up carefully. So, if we call the 79 the capital A, then opposite it, the x is the length. We call this one B, then this one is B. Now, this means that in our equation shown at above top here, we're only going to be using the first two parts because there's nothing we know on the C's, which would be this one and this side. So we're only going to be using the A and the B part. So now really it's a bit of substitution and then rearranging. So A over sine of 79 is equal to 15 over sine of 36. Now, to rearrange this, so we've got just the A on the left hand side, we need to multiply both sides by sine of 79. So the length A is equal to 15 over sine 36, and then all that is times by sine of 79. Now, make sure that when you're doing your trig questions at this point, please make sure that your calculator is set up in degrees. So you should have a little D in the top corner of your calculator for degrees. If you type that in, you get the answer 25.05 to 2 decimal places. And obviously if there's a unit here, you just need to sub in your unit, so 0.5. Now, that's the easy one, that's when we're finding a missing side. Now, to find a missing angle, you need to slightly rearrange this equation. So, if we just look at involving two parts like we have done before, so A over sine A and B over sine B. So as I say, we're just going to look at the two parts. Now, if we're trying to find a missing angle, so we're looking for the bit on the bottom, this form of the equation makes it a little bit more difficult because we're looking at 1 over for sine of the angle. So let's just rearrange this a bit. Let's try and make sine A the subject of this equation. So, to do that, we're going to times through both sides by sine A. So that means we're going to be left with A equals B sine A over sine B. Right. So let's now, to get sine A over sine B left, let's divide through by B. So A over B is equal to sine A over sine B. Now times through by sine B to leave sine A on its own. So we're going to be left with A sine B over B is equal to sine A. And there we have it, so that sine A is on its own. But the other form of the equation that most people remember is the next line, where if you divide through by the length A, you end up with sine B over B is equal to sine A over A, which is basically our original equation here flipped round. So the A and the sine A are flipped round, and the B and the sine B is flipped round. So if you're looking for a missing angle, you want the sines on top. If you're looking for a missing side, sorry, you have the little letters on the top for representing the lengths. If you're looking for an angle, then you want the sines on top. So let's have a look at an example for finding an angle. So the theta is going to be the A, so opposite it, the 7 is going to be the little a. The 75 is the B, so that one is the little b. And we're not yet again using anything to do with C, which would be the last one. So there's a bit of substitution again, subbing what we know into the equation. So sine of theta over the length 7 is equal to sine of 75 over the length 15. Let's rearrange this a little bit by multiplying through by 7. So we're left with sine theta is equal to 7 times sine of 75 over 15. And it's now a case of picking up your calculator. So sine theta is equal to 0.452, etc. Now remember, we're trying to find the angle, and what we have to do to find the missing angle is we need to use the inverse function. So we're going to use sine to the minus 1 of 0.452, etc. Remember, use your answer button from your calculator to find that theta is equal to 26.9 degrees. So as I said, you now need to remember this formula. At GCSE it was given to you, but it's not a particularly difficult formula to remember. Just remember, when you're finding the missing sides, you want it on top, and when you're looking for a missing angle, you want the sine A's, sine B's to be on top instead.